We only have 4 more derivative rules, and then you know how to take the derivative of every single function that you've ever heard of. There are other functions we haven't talked about yet, but you'll know how to take the derivative of every single function and every combination of every single function that you've ever heard of. And here's an easy one. The derivative with respect to x of e to the x is e to the x. Ladies and gentlemen, e to the x is its own derivative. So if you're going to write that with the chain rule, then the derivative with respect to x of e to the u is e to the u times du dx. So that should be in your notes at the very top of your page. We'll do an example. Can you find dy dx if y is e to the x plus x squared? So in this case, if I'm going to think of that as y equals e to the u, what's taking the place of u? It's whatever is in that exponent, right? E to the, so x plus x squared is u. So I'm going to be able to take the derivative using the chain rule. The derivative with respect to x of e to the u is e to the u times du dx. So that's my answer, e to the u, but u is x plus x squared. I'm right here. E to the u times du dx. The derivative of x plus x squared is 1 plus 2x. Make sure that this part goes in parentheses because it's a factor in a multiplication problem. That whole factor should get multiplied by the e to the u factor. Here's the second of our 4 rules. What if you want to take the derivative of some other number raised to the x exponent? Notice here a just meaning some number besides e. If that were e to the x, the derivative of e to the x is e to the x. If I want to take the derivative of some other base raised to the exponent x, that's going to be a to the x times the natural log of a. So a to the x times whatever the natural log of the base is. Or if I want to write that using the chain rule, there's a place for you to do this on your notes paper. The derivative with respect to x of a to the u is a to the u times the natural log of a times du dx. So I want to find dy dx if y is pi raised to the 3x squared. So in this case, my base, the thing that's getting raised to an exponent, is pi, so a is pi. My exponent is a function of x, that's going to be my u. 3x squared is u. I think I wrote that on the next slide. So y is a to the u, a is pi, u is 3x squared. I'm going to take the derivative using this rule that you just wrote down on your paper. Dy dx is going to be, so dy dx of a to the u is a to the u times the natural log of a times du dx. So that's what I have here. The derivative with respect to x of pi to the 3x squared is pi to the 3x squared times the derivative of the exponent, this is the du dx part, times the natural log of the base, and the base in this case is pi. Final answer. Okay, so these are the 2 that you have written in on your paper already, and we can use these now to find derivatives of logarithmic functions. So we can actually use implicit differentiation. If I want to find dy dx when y is the natural log of x, I could, the real word is exponentiate. I can exponentiate both sides. Watch this. I'm going to raise both sides. I'm going to make both sides the exponent on a base of e. But so sometimes instead of exponentiate, we say I'm going to e both sides. It's not a real word, but you can say that. And eing and natural logging are inverse operations. They undo each other. So e to the natural log of x simplifies to x. So I have a new equation that relates x and y. It's equivalent to the one I started with. And I can find the derivative. I can find dy dx by using implicit differentiation here. So take the derivative with respect to x of both sides. The derivative with respect to x of e to the y is e to the y times dy dx. Pretty sure that's going to come up on the next slide here. And the derivative with respect to x of x is 1. So I have this new equation. I'm here. I want to isolate dy dx. So I'm going to divide both sides by e to the y. Oops. Divide both sides by e to the y. You see where I am here. And now check out this cool little trick. I have here dy dx is 1 over e to the y. I'd like to leave my answer in terms of x if at all possible. So just notice that another name for y is natural log of x. Another name for e to the y is x. So we can make these substitutions in, and we get the next rule that's going to go on your paper. The derivative with respect to x of natural log of x is 1 over x. Or if I'm going to write that using chain rule notation, the derivative with respect to x of natural log of u is 1 over u times du dx. So I can use that to answer a question. If I want to find the slope of the line tangent to y's natural log of x squared at the place where x equals e squared, I'm going to need dy dx to find the slope. So dy dx is derivative of natural log of x squared. So my u is x squared. That's going to be 1 over u times du dx. In this case, 1 over x squared times the derivative of x squared is 2x. That's where I get this x, this 2x. Simplify that, although you have no obligation to on the free response section. And now I need to evaluate that at the place where x equals e squared. Move me out of the way here. So dy dx at the place where x equals e squared. Notice this notation. I hope you're practicing. It's going to be 2 over e squared. So can I write, I found the slope of the tangent line. There you go. I don't even need to write the equation. I just asked to find the slope of the tangent line. 2 over e squared. All right. So one last rule, and we'll do one last example. If I want to take the derivative of a logarithm with some other base than e. Remember, natural log means logarithm with the base e. If I use any other base besides e, I don't write ln, I write log for logarithm. And I say what the base is with this tiny letter a here. Okay, so to find the derivative of log base a of x, it's 1 over x times 1 over the natural log of a, which you can write in one big fraction like this. If I'm going to use the chain rule, that's 1 over u times the natural log of a, u and natural log of a in the denominator both, times du dx. So make sure that's in your notes paper. We'll do one last example. All right, so the derivative with respect to x of log base 5 of square root of x. Here, standing in for a, the base is the number 5. Standing in for u, the thing getting logarithmed, is the square root of x. So, to find the derivative with respect to x of log base 5 of square root of x, that's the 1 over u part. In the denominator, I also have the natural log of a in this case is 5. And then I'm going to have to take the derivative of square root of x with respect to x. We've been practicing that one a lot, so that's 1/2 x to the negative 1/2. If you wrote this answer, that would be great. That would get full credit. Feel free to write it like this and simplify too. Notice that I've had square root of x multiplied by square root of x to give that x. Final answer. Now you should make 100% certain that you have all 4 of those rules written into your notes paper. And this means you can probably do like 20% of your free response notebook now.